Hello everybody, this presentation is simply a short quiz for the subject of the completely randomized block design CRBD. We will review some of the basic concepts regarding the CRBD and we will review the formulas used to fill this table regarding the block design. This is the question. What we have here below is the ANOVA table with block design. Regarding to the significant level, it is 0.05. What is needed for this question? First, we need to fill in the blanks, simply to replace the question mark by the correct calculated values. We have another short question. How many blocks were used in this experiment? The third question is how many treatments in this experiment? D, how many experimental units or subjects in this experiment? And finally, what conclusion you can draw. So as we know, for the block design, regarding the sources of the variation, we have first for the treatments, and we have for the blocks, and we have for the error. So what is missing here in this table? First, we have to find the degree of freedom for the blocks, and we need to get the value of the SS for the blocks. We need to find the value for the mean square of the treatments and the mean square for the error. We need to find the value of the F calculated for the blocks, and we need to determine the value of the F critical for both the treatments and the blocks. So first, if you check what we have in this column for the degree of freedom, we know the degree of freedom for the treatments. The degree of freedom for the blocks is missing. The degree of freedom for the error is known, it is 20. And the total degree of freedom is known, it's 29. So simply we can use this formula. Degree of freedom total, it is simply equal to the degree of freedom for the treatments. Of course, the degree of freedom for the total is known, and for the treatment it is already known. For the degree of freedom for the blocks, this is the missing, we need to find it. And finally, the degree of freedom for the error, it's already known, so we keep the degree of freedom for the blocks in one side and move the others to the opposite side, so the sign will be changed. So the degree of freedom for the blocks is equal to the degree of freedom total minus the degree of freedom for the treatments minus the degree of freedom for the error. 29 is the degree of freedom total, the 4 is the degree of freedom for the treatments, and 20 is the degree of freedom for the error, so the degree of freedom for the blocks is 5. So this is the value of the degree of freedom for the blocks. It is 5. By the same technique, the same way, if we check for the column of the SS, the value of the SS for the treatment is known, while for the blocks it is missing. For the error it is known, and the total is already known. So the SS total is the total of all of these. So SS total is known. The SS for the treatments, again, it is known. The SS of the blocks, it is missing. We need to find it. And the SS for the error, again, it is known. So we can keep the SS for the block in one side in order to calculate for its value. So SS blocks is equal to the SS total minus SS treatments minus SS for the error. This is the SS total. This is the SS for the treatments. And this is the SS for the error. So this is the missing value for the SS for the blocks, 323.82. Here we have a short question. Is there another way to find the value of the SS for the blocks? Of course, there is another way. You should explore it. This is the SS for the blocks. Regarding the mean square, notice for the treatments, both the degree of freedom and the SS are known. So simply we can calculate the mean square for the treatments, because the formula for the mean square is simply dividing the SS for the treatments by the degree of freedom for the treatments. The SS for the treatments is known, and the degree of freedom for the treatment, again, it is known. So we can simply substitute. This is the SS for the treatments. It is inside the table. And this is the degree of freedom for the treatment. It is 4. So the value of the mean square for the treatments is simply 252.64. So this is the value of the MS for the treatments. The same way regarding to the error here, the degree of freedom and the SS for the error is already known. So we can simply find the value of the mean square for the error using the same formula. The mean square for the error is simply the value of the SS for the error dividing by the degree of freedom for the error. This is the SS for the error, and this is the degree of freedom for the error. So the value of the mean square for the error is simply 8.47. Again, we have here short question. Is there another way to find the value of the mean square for the error? Of course, there is a way. I think you should review all what we have inside this table to conclude and answer this question? So this is the value of the mean square for the error. Now what is missing in the column of the calculated F? Here we have a missing value for the calculated F for the blocks. And we know the formula to calculate the value of F is simply by dividing the value of the mean square by the value of the mean square for the error. So this is the formula how to find the value of the calculated F for the blocks by dividing the mean square of the blocks by the mean square of the error. Both of these two values are known. So we substitute. This is the MS for the block and this is the MS for the error. So this is the value of the calculated F for the blocks, 7.65. So this is the value of F for the blocks. Now the rest is only the F critical for both treatments and blocks. And in order to determine the value of the critical F for the treatments and the blocks, we need to return back to the F distribution tables by knowing three things. For example, to determine the F critical for the treatments, we need first to know the value of the probability. And the probability is simply represents the area right to the value of the F critical, and it is simply equal to the significant level, which is known to be 0.05. So we should return back to one of the F distribution table for a probability of 0.05. And we need two values for the degrees of freedom. The first one is called the degree of freedom for the numerator. It is simply the value of the degree of freedom for the treatment, which is 4. And the second value of the degree of freedom, which is called the degree of freedom in the denominator. It is simply the value of the degree of freedom for the error. It is known to be 20. So this is the way how to determine the value of the F critical. So this is the F distribution table. And regarding the significant level or the probability, it is 0.05 or 5%. In this row, we should determine the value of the degree of freedom for the treatments, which is 4. And in this column, we should determine the second value of the degree of freedom, which is the degree of freedom for the error, which is 20. So the intersection between these two degrees of freedom is the value of the F critical, which is 2.8661. So the value of the F critical for the treatments at probability of 0.05 and first degree of freedom which is equal to 4 and the second value of the degree of freedom which is 20, it is simply 2.8661. So this is the value of the F critical for the treatment. The last missing one is the value of the F critical for the blocks. The same technique. What is needed is to find the F critical for the blocks at probability of 0.05 and degree of freedom 5 and the second degree of freedom is 20. So the probability which is the same as the value of the significant level alpha which is equal to 0.05. It is given in the question. And regarding the first degree of freedom, which is called the degree of freedom for the numerator, it is simply the degree of freedom for the blocks, which is equal to 5. And the second value of the degree of freedom, which is called the degree of freedom in the denominator, it is simply the value of the degree of freedom for the error, which is known to be 20. So again, to determine the F critical for the blocks, we need to return back to one of the F distribution table for probability of 0.05, and we should get the first degree of freedom to be 5 for the row and 20 in the column. So this is the same F distribution table which we have used before. This is the probability, it is 0.05 or 5%. In this row, the value of the degree of freedom for the blocks is equal to 5. And in this column here, the second value of the degree of freedom is the degree of freedom for the error, which is 20. So the intersection between these two values of the degrees of freedom is the value of the F critical, which is 2.7109. So the value of the F critical for the blocks at a probability of 0.05 and degree of freedom for the blocks equal to 5 and degree of freedom for the error, which is 20, is simply 2.7109. So by this we finished all the missing values. Let's answer these short questions regarding the contents inside this table. How many blocks were used in this experiment? Regarding to the blocks, we already know the value of the degree of freedom and the SS and the MS and the F calculated and the F critical. So which one should we interest in? It is simply the degree of freedom, because the formula to calculate the degree of freedom for the blocks is simply it's equal to the number of blocks minus 1. So the degree of freedom for the blocks, it's already known. The number of blocks is the missing value here. So we move the minus 1 to the opposite side. So the sign for the 1 will change, 2 plus 1. So the number of blocks is equal to the degree of freedom for the blocks plus 1, which is equal 5 plus 1, which is equal to 6. How many treatments we have in this experiment? How many treatments we have? Again, we already know the value of the degree of freedom for the treatments. It's 4. And we know that the formula for calculation of the degree of freedom of treatment, it's equal to the number of treatments minus 1. The degree of freedom of treatment, the degree of freedom for the treatment is already known. It is 4. And the missing value is the number of treatments. So the same way, number of treatment is equal to 4 plus 1, which is equal to 5. How many experimental units, or sometimes it's called subjects in this experiment, which means simply the total observations, which is used in this experiment. We know that in order to calculate the degree of freedom, the total, we know that the total degree of freedom is equal to capital N minus 1. And capital N here represent the number of the units or experimental units used in the experiment. So we can simply count for the value of the N. It's equal to the degree of freedom total plus 1. So 29 plus 1 is equal to 30. So we have 30 experimental units used in this design. Is there another way to calculate for the capital N? I'll leave it to you in order to answer it. What conclusion can you draw? So this is the last question. And this is an important question. So regarding the treatments, we already calculate the value of F, which is 29.83, and it is significantly greater than the value of the F critical. So simply for the treatments, there is significant for the treatments, which means that we reject the null hypothesis for the treatment and accept the alternative one. The alternative hypothesis for the treatment states that the means of the treatments are not the same, or at least one of the means is not the same as the other. Regarding to the blocks, the same way, the value of the F calculated or statistic F is greater than the value of the F critical. So again, for the blocks, there is a significant, which means that we reject the null hypothesis and accept the alternative one. And the alternative hypothesis for the blocks states that there is a difference between the blocks regarding the means. Or for example, let's say one of the means is not the same as the other. So this is the conclusion here. Regarding the treatments, the value of the calculated F is significantly larger than the value of the F critical at 95 level of confidence. So we reject the null hypothesis and accept the alternative one, and the alternative states that the means for the treatments are not equal, or at least one of the means is not the same as the others. Regarding the blocks, the F calculated for the blocks again is larger than the F critical at 95% level of confidence. So again, we have enough confidence to reject the null hypothesis and accept the alternative one. And the alternative hypothesis for the blocks states that the means for the blocks are not the same, or at least one of the means of the blocks is not equal to the others. So this is the conclusions that we draw from the contents inside the ANOVA table. Thanks a lot. Goodbye.